Hello and welcome students. Today we will discuss the topic atmosphere. First we will discuss what is atmosphere. So the atmosphere is a multi-layered gaseous envelope surrounding the earth. The atmosphere is attached with the earth by its gravitational force. It also filters the incoming solar radiation reaching the earth's surface and protect the earth from becoming too hot or too cold. About 97% of the effective atmosphere is up to the height of 32 kilometers. In this topic, we will discuss the different layer of the atmosphere, air pressure, transfer of heat energy, earth-atmosphere energy balance and hydrologic cycle. Our atmosphere is composed of many gases. Some of them are permanent gases and some are variable gases. Permanent gases are always present in the atmosphere. These are mainly nitrogen, oxygen and argon. Nitrogen is 78% by volume present in the highest amount in the atmosphere. Next to this is oxygen, which is present about 21% by volume in the atmosphere. Then argon and carbon dioxide. Some variable gases are also present in the atmosphere. The concentration of these gases changes from time to time and from place to place. Some of these gases are important to weather and climate. Main of these variable gases are water vapor, carbon dioxide and ozone. Next to this is the different layers of atmosphere. Our atmosphere consists of 4 spherical layers arranged vertically. The layered structure of atmosphere has been classified on 2 major considerations. The first is thermal characteristics and the second one is chemical composition. The Earth's surface is divided into 4 vertical layers. First is troposphere. Troposphere is the lowermost layer of atmosphere. Almost all of the weather phenomena occur in this layer. This is the layer where we live and it is up to 8 to 12 miles in height. Temperature decreases with increasing height at the rate of minus 6.5 degree centigrade per kilometer and this is called the normal lapse rate. जैसे जैसे हम ऊपर जाएंगे वैसे वैसे टेम्परेचर डिक्रीज होता जाएगा. And the boundary of the upper limit of the troposphere is called tropopause. The decrease of temperature stops at this point and hence it represents a cold point. The tropopause means where the mixing stops. The turbulent mixing stops at tropopause. The next layer is stratosphere. This is the second lowest layer. This layer is just above the tropopause. ये लेयर ट्रोपोपॉज के जस्ट ऊपर वाली लेयर होती है and the average height is taken to be 50 kilometers. Temperature rises in this layer with increasing altitude. आप जैसे कि पिक्चर में भी देख रहे हैं टेम्परेचर बढ़ता जाता है हाइट्स के साथ. This layer is characterized by near absence of weather phenomena because of stable conditions. The lower part of stratopause is very important for life forms in the biosphere ecosystem because there is concentration of ozone between the height of 15 to 35 kilometers. This portion of stratopause is known as ozonosphere. Ozone is very important for life because it absorbs most of the damaging ultraviolet sunlight. So, the upper limit of stratosphere is known as stratopause. Next to this layer is mesosphere. Meso means middle. It extends between 50 to 80 kilometers or 30 to 53 miles. In this layer, temperature decreases with increasing height at a rate of -5 degrees centigrade per kilometer. At the uppermost limit of mesosphere, temperature becomes -80 degrees centigrade and may go down as low as -100 degrees centigrade to 133 degrees centigrade. This limit is called mesopause. In this layer, noctilucent clouds formed through the process of condensation. Noctilucent clouds are the highest clouds of the atmosphere. This layer is characterized by very low air pressure, ranging between 1.0 millibar at 50 km altitude, representing stratopause, and 0.01 millibar at mesopause at 90 to 100 km. Fourth layer is thermosphere. This is the upper atmosphere and it is about 53 to 430 miles. It is above the mesopause layer. Temperature increases rapidly with increasing height. जैसे जैसे हाइट बढ़ती जाती है इस लेयर में टेम्परेचर इंक्रीज होता जाता है. It is divided into two layers. First is ionosphere and the second is exosphere. Ionosphere extends from 80 km to 640 km. There are many ionic layers in this sphere. And in the exosphere, uppermost layer of the atmosphere, the density becomes extremely low. And the atmosphere above ionosphere is called outer atmosphere, having exosphere and magnetosphere. And this zone is characterized by von Allen radiation belts having charged particles trapped by Earth's magnetic field. So this is all about the four layers of atmosphere: troposphere, stratosphere, mesosphere and thermosphere. Next to this is upper air radiosondes. In order to measure the conditions of the lower atmosphere, the National Weather Service utilizes an upper air network across the country. वेदर प्रेडिक्शंस के लिए अपर एयर एटमॉस्फेयर को यूज़ किया जाता है और नेशनल वेदर सर्विस इसको कई तरह से मेजर करने के लिए प्रैक्टिस करता है. तो इसके लिए क्या करते हैं, जो बैलून्स हैं फिल्ड विद हाइड्रोजन ये छोड़े जाते हैं और द बैलून्स फिल्ड विद हाइड्रोजन measure about 6 feet wide by 6 feet tall when released, and when a balloon reaches nearly 50,000 feet, the balloon has significantly increased in size. The instruments pictured above measures temperature, pressure, wind, humidity and wind speed at various levels from the ground up to 50,000 feet. इस पिक्चर में जो इंस्ट्रूमेंट दिखाई दे रहा है ये विंड की स्पीड, प्रेशर, टेम्परेचर इन सब को मेजर करता है और इससे जो डाटा कलेक्ट होते हैं वो दूसरे डाटा के साथ मिला करके उनसे वेदर का प्रेडिक्शन किया जाता है. तो ये इस पिक्चर में ये दिखाया जा रहा है कि अपर एयर के एटमॉस्फेयर को नेशनल वेदर सर्विस द्वारा यूटिलाइज किया जाता है वेदर प्रेडिक्शन के लिए. इसमें ये बैलून दिखा रहे हैं और ये बैलून्स जो हैं हाइड्रोजन से भरे हुए होते हैं, 6 फीट वाइड और 6 फीट टॉल होते हैं और इन्हें रिलीज़ किया जाता है. ये मॉर्निंग में और इवनिंग में 2 बार ऐसा किया जाता है वेदर को प्रेडिक्शन करने के लिए. इसके बाद वी विल डिस्कस द एयर प्रेशर. द एयर प्रेशर इज सिंपली द वेट ऑफ एयर above an object. The weight of air is directly related to the number of air molecules in a given volume. So, air pressure depends on the number of air molecules in a given volume above an object and how fast the molecules are moving. Density of molecules decreases with height. जैसे जैसे height बढ़ती जाती है molecules की density कम होती जाती है. Although the atmosphere goes up to 184 miles, half of the atmosphere is in the first 18,000 feet or 3.4 molecules. Less molecules higher up makes it is harder to breathe than at sea level. Air pressure is converted to sea level pressure to observe surface low and high pressures. Otherwise, the Rocky Mountains would be always be low pressure and the oceans would be areas of high pressure. So, the amount of air over us is constantly changing. As a result, the weight of air called pressure is constantly changing. These changes in air pressure are measured by taking the sea level as standard. So, pressure also dependent upon temperature. जैसे एयर प्रेशर एक्चुअली क्या है, जैसे जैसे ऊपर बढ़ते जाते हैं एयर प्रेशर कम होता जाता है. जैसे कि पहाड़ों पर ऊपर जाते हैं और ऊपर जाते हैं तो एयर प्रेशर कम होता जाता है. दिस इज़ बिकॉज ऑफ द डेंसिटी. बैरोमीटर इज द barometer is the instrument by which we can measure the air pressure. Air pressure can be measured in inches of mercury or millibars. Barometer is discovered by Torricelli in 1643. This is an instrument by which we can measure the air pressure. The unit of atmospheric pressure is Pascal. We can measure atmospheric pressure in inches of mercury or in millibars. Sea level pressure is known as the standard pressure. बाकी सारी जगहों का प्रेशर हम सी लेवल के प्रेशर से ही उसके कंपैरिजन में ही मेजर करते हैं. So this is all about the today's lecture. This is some idea about surface pressure. In this picture, some area represents the blue line and some red line. Blue line represents the high pressure and red line represents the low pressure. So this is all about the today's lecture. Thank you for watching.